Hi, so today we're going to talk about Section 3.3 information, which is linear equations in two variables. So you will have seen some of this information before, but just to remind you of what our goal is for this section is we want to be able to identify linear equations in two variables, x and y, identify intercepts of the coordinate axes, and learn about horizontal and vertical lines. So let's start with a definition. A linear equation in two variables, say x and y, is an equation that can be written in the form ax plus by equals c, where a, b, and c are constants, and a and b are not both zero. This form of an equation like this is standard form. This is standard form. So you'll want to remember this because throughout the rest of the chapter, you will see this. Okay, so remember, this is a linear equation in two variables, and we say that is the standard form. Okay, so in example 1, what we want to do is we want to determine if the following equations are linear. Okay, so we want to see if it has this similar format involved or if it can somehow be arranged that way. Okay, so we have 9x plus 4 times the quantity y minus x equals 3. Well, initially it's not in that form, but so far we have two variables, x and y. So not bad. So let's simplify a little bit. We have 9x plus, distribute the 4 to get 4y, minus 4x equals 3. Combine like terms, 9x minus 4x is 5x. So then we get 5x plus 4y equals 3. And go figure, yes, this has this form, so this is a line. This is a line, yes. This is linear. Okay, so let's check a few more. So in part B, we look here. We have 3x plus xy equals 2y. But wait a second. Here we have a product. We didn't see that in the standard form, so that's a red flag. So remember, the standard form is ax plus by equals c, where a, b, and c are constants. So this is not linear because it has a product x times y. Okay? All right, so not linear. Now, we have the quantity in C, in part C, we have the quantity x plus y squared minus the quantity x minus y squared equals 1. And initially, we see these squared terms and we're like, wait a minute, exponents will have degree 2, but maybe we can simplify. It doesn't look like it, but let's check to confirm. So once you use the FOIL method, you expand. Remember, you have x plus y, quantity squared is x plus y times x plus y, minus the quantity x minus y times x minus y equals 1. So then we get, using the FOIL method here, we get x squared plus 2xy plus y squared minus the quantity. When you FOIL here, we get x squared minus 2xy plus y squared. All of that is equal to 1. But now you distribute your negative here and there. So we get x squared plus 2xy plus y squared minus x squared plus 2xy minus y squared equals 1. And it confirms what we thought. So we have some terms. This x squared cancels. The y squared is canceled too. So maybe there's some hope, but we rewrite, combine like terms. You have a 2xy here and a 2xy here. That gives us 4xy equals 1. But that's a problem because we have a product xy. So we don't have products in our standard form. So the answer here is it's not linear because it is our equation, has the product xy in it. Okay, what about D? D, we have x minus 3 equals 4x plus 17 over 5. Now, initially you may have a moment of pausing here because you see this rational expression on this side. But do not panic because we can multiply both sides by 5 to eliminate that rational expression. Let's do that. Multiplying both sides by 5, we get 5 times the quantity, x minus 3, equals 4x plus 17 over 5. We're multiplying it by 5, so notice that the 5s here will cancel, giving us 5x minus 15. Where did that come from? Distribute the 5. Equals 4x plus 17. Combine like terms, that gives us 5x minus 4x equals 17 plus 15, which means x is equal to 32. And you may be thinking, but wait, it does not have a y term here. We just have x equals 32, and our standard form is ax plus by equals c. Well, the number in front of x is 1. There is no y term here. You are correct. But that just means b is 0. So we could write this. So first, is it linear? Yes. This is linear. Because we can rewrite this as x plus 0y equals 32. Okay? The coefficient of y is 0, not 2. It's 0. Okay? So it turns out that if you graph it, if you have an equation of the form x equals 32 or x equals a number, then it's a vertical line. So if this is 32, x equals 32 is this line. Okay, this is the line x equals 32. So yes, it is a line. It just happens to be a vertical one. Okay, so now we want to move on to our second goal in this section, and we want to talk about the intercepts of the coordinate axes. The intercepts of the coordinate axes. So let's start out with definitions here. Any point where the graph intersects the x-axis is called an x-intercept. And these x-intercepts are of the form c, 0, where c is a number. So for example, if you have your plane here and you have this line, this point here is the x-intercept. Okay, that's your x-intercept. And if we call this negative c, that would be negative c, 0. Okay, now, any point where the graph intersects the y-axis is called a what? It's called a y-intercept because it's crossing the y-axis. These are of the form 0, c. So in other words, x is 0, and you write down the y value for whatever is crossing. So for example, if we go back to this graph here and this line, this point here is our y-intercept. We'll put that in green. That's our y-intercept. So if that value is D, then the respective y-intercept is 0, D. Okay? So now let's apply this information. Find the x and y intercepts of the given equations and sketch the graphs. You need 2 points to sketch a line, so we're hopeful. Okay, so you have y minus 3x equals 9. We want to find the x-intercept and we want to find the y-intercept. So let's do that. So whenever you're finding your x-intercept, notice that here it has this form, which means y always have to be 0. So to find your x-intercept, that means you set y equal to 0 and you solve. Okay, so we're setting y equal to 0 and we solve. That gives us 0 minus 3x equals 9, or negative 3x equals 9. Divide by both sides by negative 3 to get x equals negative 3, which means the point negative 3, comma 0 is our x-intercept. Remember, this 0 comes from setting y equal to 0. Okay? So far, so good. Now, we need to find our y-intercept. And guess what we're going to do? We're going to set x equal to 0. We're going to set x equal to 0, and we're going to solve. So, setting x equal to 0 in our equation gives us y minus 3 times 0 equals 9, or y minus 0 equals 9, which means y equals 9. Okay? Which means our y-intercept has the ordered pair 0, comma 9. Okay? Perfect. So now what we want to do is we want to graph. So sketching the graph, we plot those 2 points that you found. We're sketching. Okay? So we go over to negative 3. We plot this point. That's our x-intercept. And then we plot our y-intercept. Go to 0. Go up 9. Let's say that's 9. And then we draw a line. Okay? So there you go. That's y minus 3x equals 9. Okay, perfect. Pause the video and do part B. You have y minus 2x equals y minus 4. Okay, now let's keep moving. Did you pause your video and try it? Hopefully you did. Now let's continue. So remember, our goal is to find the x and y intercepts of the given equations and sketch the graphs. So we have y minus 2x equals y minus 4. So let's find our x-intercept. Remember, you set y equal to 0 and you solve. Okay, so we have negative, or 0 minus 2x equals 0 minus 4, which means negative 2x equals negative 4. Divide both sides by negative 2. That gives us x equals 2, which means because y is 0, our x-intercept is 2, comma 0. Okay, great. So now let's find our y-intercept. And how do we do that? We set x equal to 0 and we solve. So let's do that. Whenever we do, we get y minus 2 times 0 equals y minus 4. Well, this gives y equals y minus 4. But subtract y from both sides, we have y minus y equals negative 4. But that means 0 equals negative 4. That's not true. That's not a true statement. Which means that there's no y-intercept. There's no y-intercept. So it turns out what we have here is a vertical line. We have a vertical line. So we have our x-intercept is 2, 0. And we have this is our graph. That's our graph. Okay? So this is the graph of y minus 2x equals y minus 4. Okay, awesome. Let's keep going. So a couple of facts to end the section, which was our third goal. was to talk about horizontal and vertical lines. And we've already seen an example of what a vertical line would be. Let's talk about the other form as well. Horizontal lines are of the form y equals a number, where a is a constant. Okay, so y equals a, where a is a constant. For example, if we have y equals 2, that means we need to go start at 0, go up to 2, and draw the horizontal line. So that's the horizontal line here. Okay, vertical lines are of the form x equals a, where a is a constant. So for this example, we have x equals -1. You go start at 0, go to -1, draw your vertical line. There you go. This is section 3.3. Make sure you do your own work. Have a good one.